Today, we're going to crack the code on something that can feel a little tricky at first, decimal division. But I'm going to let you in on a little secret. It is way, way simpler than it looks. So let's jump right in.
Okay, so you see a problem like this. That little decimal point in the middle. It just looks kind of scary, right? It feels like it complicates everything. But what if I told you that little dot is actually the key to making this whole thing super easy?
You see, the real secret here is that you've already got the main skill you need, just basic normal division. We're just adding one tiny little step. So think of that decimal point not as the bad guy in this story, but as your friendly guide pointing you exactly where you need to go.
To really get this, we've got to go back to basics and look at the decimal's big secret, how it's connected to dividing regular old whole numbers. Seriously, this is the foundation for everything else we're about to do.
Let's start with something you do in your sleep. 628 divided by 2. We all know that's 314, right? No decimals, no tricks, just simple math. Now just lock that number, 314, in your brain for a second.
So, what happens if we change it to 62.8 divided by 2? We just made our first number 10 times smaller. And, would you look at that, the answer, 31.4, is also exactly 10 times smaller. See that? A pattern is definitely starting to show up here.
Okay, let's do it one more time. 6.28 divided by 2. And, just like clockwork, the answer is 3.14. This is the big secret. The decimal's position in the problem is just a mirror of its position in the answer. The actual math, the dividing part, it doesn't change at all.
Okay, now that you're in on the secret, let's open up our detective's toolkit. There are two main ways we can solve our original problem, and honestly, both of them work perfectly.
So we've got two roads to the right answer. We can use the fraction method, or we can use the long division method. They look a little different, but trust me, they both lead to the exact same treasure at the end. Let's see how they work.
First up, the fraction method. Now this one's pretty clever, because it just gets rid of the decimal for a minute. We turn 29.61 into a fraction, which is 2961 over 100. Then we just divide that top number, 2961, by 7. That gives us 423. And for the last step, we put that 423 back over 100 and turn it back into a decimal, and we get 4.23. See? Easy.
All right, next up is the one you'll probably see the most, long division. This one's super direct. First, you set up the problem, then, and listen up because this is the golden rule, you take the decimal point and just bring it straight up into your answer line. Do that before you do anything else. Once it's there, you can basically ignore it and just divide 2961 by 7 like a totally normal problem, and you get the same exact answer, 4.23.
So, you've got the main methods down pat. But every now and then, a sneaky little character likes to show up in these problems. 0. Let's take a look at a few special cases so you're never caught off guard. So what do you do if the number you're dividing is actually smaller than the number you're dividing by, like 5.34 divided by 6? Well, just think about it. You can't make a group of 6 out of just 5, right? That's impossible. And that's your big clue that the answer has to be less than 1. It's got to start with 0 point something.
So whenever you see a problem like this, the very first thing you do is put a 0 and a decimal point in the answer. Once you've done that, you can just look at the first two digits as a whole number, in this case 53, and divide like you normally would, and you'll find the answer is 0.89.
Okay, here's another thing that happens all the time. You're dividing, everything's going great, and then you run out of numbers to bring down. But wait, you still have a remainder. What now? The solution is actually pretty cool. You can add as many zeros as you want to the end of a decimal, and it doesn't change its value at all.
Let's try 3.4 divided by 5. After you do the first part of the division, you've got a remainder. No problem, we just add a 0 to the end of 3.4, making it 3.40. Now we can bring that brand new 0 down, and that gives us the number 40. And hey, 40 divides by 5 perfectly. That little 0 we added lets us finish the problem with a nice, clean answer, 0.68.
Now, this might be the trickiest one, but the rule is still really simple. Let's take 16.4 divided by 8. Okay, 16 divided by 8 is 2. Easy. Now we bring down the next number, which is 4. Can you divide 4 by 8? Nope. When this happens, you have to put a 0 in the quotient. It's like a placeholder. Then you can add another 0 to the end, bring that down, and solve 40 divided by 8 to get 5. So your final answer is 2.05.
All right, that's enough with the theory.
Let's see how this stuff actually works in a real-world problem.
Imagine you're designing a park. You have a little road that's 9.45 meters long, and you've got to plant 10 trees at perfectly equal intervals. How far apart do you plant them? Now, your first instinct might just be to divide by 10, but hang on, there's a little catch.
Here is the secret to solving problems like this. We don't really care about the number of trees. What we care about is the number of gaps between the trees. Think about it. If you have 2 trees, there's only 1 gap between them. If you have 3 trees, there are 2 gaps. It's always 1 less. And that's the number we actually need.
So the solution is just a simple 2-step process. First, we figure out the number of gaps. 10 trees means there are 9 gaps. Second, we take the total length of the road, 9.45 meters, and we divide it by those 9 gaps. That's our real division problem.
So you do the division, and there you have it. 1.05 meters. Each tree needs to be planted exactly 1.05 meters apart from the next one. And just like that, decimal division helped us build a perfectly landscaped street. Pretty cool, right?
We have covered a whole lot of ground. So before we wrap this up, let's just go over the final clues that will make you a master decimal division code cracker.
Just remember these 4 golden rules. 1, the very first thing you do is put that decimal point in your answer. 2, once that's done, just pretend it's not there and divide like they're whole numbers. 3, if you get a remainder but run out of numbers, just add a 0 to the end and keep going. And 4, don't be scared if you have to put a 0 in your answer. It's just holding a place for you.
You've now officially cracked the code for dividing a decimal by a whole number. But you know how it is. Every solved puzzle just reveals a new one. What happens when you have to divide a decimal by another decimal? Well, that's the next level, and we'll tackle that mystery next time.